Today we are going to be doing 9.2, which is solving quadratic equations using square roots. And it turns out you guys really already know how to do this. There's just one trick that I want to make sure that you're doing, so it should be pretty quick. Our learning goal for today, I will solve quadratic equations by taking square roots. So this, like I said, it's very straightforward. It's stuff that you've really already done before. We just are going to learn one special thing that we'll need to make sure we're doing. So starting off, this is going to be a very easy one. Let's do 2x squared minus 32 equals 0.
Why
And
is that your hand?
because I'm making a video, I need you to go in the other room, Matthew. This is what happens when I make videos at home. So I'm going to add 32 to each side first. I can't do anything with that 2x squared. That's paired up right now. So I add 32 to each side. I get 2x squared equals 32. Divide each side by 2 next. So I'm left with x squared over here. I'm left with 16 on this side. And, yep, go ahead. So x squared equals 16. Now, in order to undo a square, I need to take the square root of each side. So what you might be thinking is, oh, then x equals 4. You want to be careful, though, because remember that 4 squared is 16 and negative 4 squared is 16. So instead of just 4, negative 4 is also an option here. And the way that we're going to write that is using the plus or minus 4. So we could say x equals plus or minus 4. If you only have positive 4 for your answer, you're only half right because you're missing an entire other solution. If I substitute negative 4 in for x here, what was it? Minus 32 equals 0. If I substitute in negative 4, my order of operations says to do that exponent first. So negative 4 squared is 16. And we're checking to see if that works. 2 times 16 is 32. And 32 minus 32 equals 0. So you can see that negative 4 is a solution, which means it needs to be part of our answer. So there's our first example. Our next example is going to look like this, and really it's using the same method. Just in this case, we're not equal to 0. The first thing we want to do is subtract 8 from each side. When we do that, we get 5x squared equals 0. And from here, it's pretty obvious what x is going to be, but let's keep solving anyway, just to get used to it. So I divide each side by 5. 5x squared divided by 5 leaves me with x squared. 0 divided by 5 is 0. So if x squared is 0, the square root of 0 is 0. So in this case, I only have one solution, and that's x equals 0. So if you think back to our graphs, remember yesterday you had a graph that looked like this maybe. You had a graph that looked like maybe something like that. Or you could have a graph that looked like that. So this was a 2 solution case. This was a 1 solution case, and this was no real solutions. So our first example, we had 2 solutions, positive or negative 4. That graph would maybe look something like this. Obviously, it could really be anywhere, but that's the general idea. Our second example, we had x equals 0, so it would be a graph of a parabola that just touches the x-axis. So then, of course, our final example, I know this is going to shock you, is going to be this third case. So let's see what that might look like. If I had x squared plus 8 equals 5, when I subtract 8 from each side, I get x squared equals negative 3. Now remember, there's no number that we square that gives us a negative. So when I take the square root from each side, the square root of negative 3 has no real solutions. So When you're in Algebra 2, you'll talk about imaginary numbers, and that's where those will come into play when we have square roots of negatives. But for now, we just say there's no real solutions. So these are our three possibilities when we're solving quadratics using square roots. Actually, when we're solving any quadratics, but this is what they look like using this method. Now, I know that's super easy. I'm just going to show you two more examples, and then you'll be done for the day. Okay, this example is set up just a tiny bit differently, so we need to make sure that we're doing our steps in the correct order. So we have x squared minus 1, and that quantity is what's squared, and that equals 25. So what I'm going to do is I have to undo that square to break that x minus 1 out of the parentheses. So I need to take the square root of each side first. When I do that, over here, I'm left with x minus 1. And on this side, I'm left with positive and negative 5, or plus or minus 5 is another way to say that. So when I do that, x minus 1 either equals positive 5 or x minus 1 equals negative 5, which means I have two possibilities here that I need to solve. So this is going to break into two separate equations. So again, if you only do the positive 5, you're only going to get half of your answer. So make sure that you're following the steps and you're going through and not forgetting that square roots can result in a positive or a negative. So on this one, I'm going to add 1 to each side, and I just get x equals 6. For this guy, I add 1 to each side, and I get x equals negative 4. So this was another example of two solutions, but when I was solving, I had to do it a little bit differently because I had a quantity squared, not just an x squared. So my solutions here would be x equals 6 or x equals negative 4. So finally, we have a word problem with a water tank with a height of 3 feet and the length is 3 times the width. The volume of this tank is 450 cubic feet, so we want to find the length and width of the tank. So basically we have this rectangular prism. Okay, in a few minutes, we have this rectangular tank here where we have 3 feet high, but we don't know the length or the width. But we do know that the length is 3 times the width. So, and then our total volume is 450 cubic feet. So remember, volume of a rectangular prism is length times width times height. So let's substitute in 3w, or 3 times our width for our length, and let's substitute in 3 feet for our height, and then we know that our volume is 450 cubic feet. So let's simplify this side first. I have a 3 times a 3, which is 9, and w times w is w squared. So here you can see that's where our quadratic comes into play. I'm going to divide each side by 9 first. 45 divided by 9 is 5, so 450 divided by 9 is going to be 50. And then I'm going to take the square root of each side to undo the square. The square root of 50 is about 7.1. I'm estimating a little bit. Square root of 49 is 7. If you have a calculator, obviously, you can punch it into your calculator and you'll get about 7.1. So our width is 7.1 feet, approximately. And then our length is 3 times our width. So that's going to be about 21.3 feet. So this problem really was not very complicated at all. You just had to remember your formula for a rectangular prism volume. So there you have it. That's this whole section. I think it's, like I've said a million times, I think it's pretty straightforward. Just solving equations like you've done in the past, just now we have squares. Your homework is on page 466. You're going to do numbers 1, 2, 12 through 28 even, and 30 through 40. So go ahead, you can look at the examples in your book too. The ones I did were a little bit different except for one of them. Look through those and you should be good to go. So good luck.